range of scales in which humans are able to sense is very limited compared to the true nature of reality. When thinking about special relativity, we first consider speeds intuitive to our everyday experiences. Galilean transformations are used to calculate the velocity of a ball thrown between two people. The velocity of the ball is relative to each person and is additive or subtractive depending upon their motion. In the case of constant velocity, each observer is equally correct in claiming he or she is at rest, and it is in fact the other object moving. According to the girl, the bus is rushing by. However, according to the bus, the girl is rushing by. In the 1800s, James Clerk Maxwell correctly hypothesized that light was an electromagnetic wave and correctly calculated its propagation speed. Michelson and Morley set out to find evidence of a substance that light propagates through, known as the ether. To their surprise, it was a non-result, and hence proved the speed of light was constant, in which Einstein based his work upon. To test the implications of this result, we can devise a thought experiment in which a boy and a girl are sat at equal distances away from a light source on a train. When the train is stationary, it is agreed upon by the observer on the platform and the two people that the light reaches their eyes at the same time. Repeating this experiment while the train is moving at constant velocity gives tremendous results. As the train moves, the two people continue to experience the light hitting their eyes at the same time. But according to the observer on the platform, the light is reaching the boy before the light reaches the girl. This is not some kind of trick of the eye. The exciting conclusion of this result is that different observers experience events at different times depending upon their relative motion. This is all due to the fact that the speed of light is constant. A light clock can be used to demonstrate the effects this has on time in relative motion. As the clock moves at constant velocity, from the perspective of the observer, the clock in motion is ticking more slowly, relative to their own. This is due to the perceived trajectory of the moving clock according to the observer at rest. However, as we've seen previously, each clock is equally correct in claiming they are at rest and the other is moving. Therefore, each clock is able to claim the other is ticking more slowly. What Einstein discovered is incredible and goes against all our intuitive experiences. Approaching the speed of light causes time to slow down for you relative to an observer at rest. Upon your return to that observer, you would find that you had aged considerably less. So, an answer to the question, is time travel possible? Theoretically, yes. Approaching the speed of light is a difficulty, but let's leave that for another day. This has been a Tachyonic Physics production.